Today, we'll do the proof of the sum of n terms of an arithmetic progression. Prove that for an arithmetic progression, Sn is equals to n over 2 to a plus n minus 1 into d, where a is the first term, d is the common difference, n is the number of terms. Sn is equals to Sn is the sum of first n terms. Proof. As is the first term and the common difference is d, so I can write the sum of n terms as equals to a plus d, the next term. Third term is a plus 2d, and so on, so on, and so on. And at some stage, it would be the last term we know is a plus n minus 1 into d, the last term, and the term before that is a plus n minus 2 into d. So we have, so keep in mind that the last term is here, and this last term is the nth term, and the question was to find the sum of n terms. First term is a, second term is a plus d, third term is a plus 2d, and so on. The last term is a plus n minus 1d. So you can mark this as 1. Next, you can write the sum. So no matter if you write the last term first and the first term the last, it would not make any difference. So a plus n minus 1d, which was the last term, plus a plus n minus 2 into d, the second last term, and so on and so on. It would be a plus d and finally plus a. So the same thing, the same sum, but writing in the reverse order. Next, I'll add 1 and 2. Add 1 and 2 equations. So left side will be added to left side and the right will be added to the right side. When we add left side to left side, we get s n plus Sn is s2n. So I'm going to add the 2. So adding in this order, add a to this term, then a plus d to this term, then a plus n minus 2 into d. I'm just adding the corresponding terms to a plus d, and finally I'll add the last term to the last term. So just to clear this concept, I'm writing them side by side because so I'm going to add 1 and 2. So a added to a plus n minus 1 into d, a added to a plus n minus 1 into d is equals to 2a plus n minus 1 into d. You can easily understand this thing. The second term, a plus d, added to the second term of equation 2 is a plus n minus 2 into d. So you can simplify. So a plus a is 2a plus d plus, so n minus 2 into d. What I can do, I can take common d from the last two terms. So it is 1 plus n minus 2, and finally 2a plus n minus 1 into d. So I added first term to the first term, second term to the second term. You can mark this as 1, this as 2, because, and so on. And so on. Coming to the second last term, a plus n minus 2 into d. So a plus n minus 2 into d. So if you keep on adding, so a plus n minus second last term, so on, so on. So this term, a plus n minus 2 into d, when we add this to the second last term of the second, we will just adding the corresponding terms. So a plus a is 2a. The rest is n minus 2 into d plus d. 2a will remain 2a. And from these two, if we take d common, inside is n minus 2 plus 1. And see, we're getting the same thing, 2a plus n minus 1 into d. So it means that the sum of the first term added to the corresponding term for the second. So a plus n minus 1 into d is coming from here. When I added second term to the second term of the second equation, the answer is the same. When I added the second last term to the second last, is the same. And yes, last term is a plus n minus 1 into d. A plus n minus 1 into d added to a, the last term of the second. So a plus a is 2a plus, I'm just writing d terms, n minus 1 to d, that's it. So we have the fourth in this way. So there are many terms. So that when we are adding the corresponding in the first to first, second to second, third to third, and second last to second last. So because we are adding the two equations, we just add 1 and 2. So left hand side, so Sn plus Sn plus Sn. So therefore, by adding 1 and 2, left side added to left side is 2Sn, is 2Sn is equals to, now see, there are n terms. There are n terms. So it means that 2a plus n minus 1, 2a plus n minus 1 is there. Then again we are adding 2a plus n minus 1 to d to this, and so on. And when we check, the second last term was the same, 2a plus n minus 1 into d, and the last term is again 2a plus n minus 1 into d. And yes, there are n terms. There are n terms. So it means that on the right hand side, we are adding the same thing n times. So left hand side is 2Sn. So as 2a plus n minus 1 into d, 2a plus n minus is repeatedly there and n terms are there. So I can say that 2a plus n minus 1 into d, and sum of these n terms is n multiplied by this. This is similar to the situation when we have 4 plus 4 plus 4 plus 4 plus 4 plus 4 5 times. So 4 multiplied by 5 is the answer 20. Instead of adding 4 plus 4, 8, 8 plus 4, 12, 12 plus 4, 16, 16 plus 4, 20. Why not to just multiply 4 by the number of times it is appearing there. So the sum is 4 multiplied by 5, and like that. So we have the brackets, all the brackets same, all the brackets same, and there are n terms. So just multiply that by n. So finally, dividing by 2, we have n over 2, 2a plus n minus 1 into d. So this is the formula for the sum of sum of n terms of arithmetic progression. Yes, you know this formula. So 2n over 2, 2a plus n minus 1 to d. So we know what is ab, what is a, d, n, and sn. So the proof is here. So first I wrote Sn by adding the different terms of AP, n terms, and then I wrote in the for the second equation, I wrote the sum in the reverse order. And so by writing the sum in the reverse order, we have different terms there. So then I added 1 and 2. So I added first term to the first term, second term to the second term, and just to create this thing. So this working is very important. So I added first term to the first term. We have 2a plus n minus 20d, and so on. So the answer, the sum is coming the same. Each time we're getting 2a plus n minus 1 into d. And so when we are adding 1 and 2, left hand side is Sn plus Sn 2 Sn. The right hand side, we have the same thing repeatedly there for the for n times there, and the sum is there. So in order to get the sum of the right hand side, just multiply 2a plus n minus 1 to d by n, and by dividing by 2, we have the answer. Thank you.